And welcome to Gaffey's Grinds. In today's video, we're going to walk through the titration question in the higher level paper from 2011. All right, so it was on the bleach titration, so trying to find the percentage or the quantity of hypochlorite ion in bleach. So without too much more chat, we're going to jump into it. You're going to need your calculator, periodic table. You're going to need some paper to write on, and if you've got a copy of the exam papers, grab it and open it up to this question, 2011 question 1. Right, so what I'm going to ask you to do is to read along in your exam papers, and we have an introductory piece of text. There may be some important information in here, so what I'd like you to do is pause your video and highlight anything that you think is important. All right, so it says that chemists determined the concentration of bleach, solution containing sodium hypochlorite NaClO by volumetric analysis. So this is obviously one of our substances. And as you can see, the NaClO is what gives us this ClO minus ion. So I'm going to highlight this green and highlight this green to show that this gives us this. It then says a 25 centimeter cube sample of the bleach was first diluted to exactly 500 cm cubed. So what I want you to think about is what type of dilution is that? What factor is it? 1 in how many? Okay, so pause in the video and writing that down, please. All right, so this is 25 centimeters cubed diluted to 500. Hopefully you realize, well, if I dilute it by 10 or 1 in 10 dilution, that would be 250. And we have twice that volume now. So 25 to 250 will be 1 in 10. So 25 to 500 is 1 in 20. 1 in 20 dilution. So that is going to be important information later on. And hopefully you were able to see that for yourself. Okay, it then says a pipette was used to measure 25 centimeters cube volume of the diluted bleach. So as I can see, this is the substance that's in the bleach. So this is what we're transferring for the titration. 25 centimeters cubed of the diluted bleach, so the solution that we diluted and transferred to the conical flask. So the diluted bleach is in the conical flask, all that's in blue. It then says solutions of potassium iodide, Ki, and sulfuric acid were added. So hopefully you can see here that those, now change my highlighter, sorry, those here, so this Ki solution gives us the iodide ions. And then it says sulfuric acid in pink, sulfuric acid, and that gives us the hydrogen ions. So there we have the three things together in the conical flask to give us this first chemical reaction. We've produced Cl minus, I2, and H2O. Now, if we make these three things, this here is going to dominate in color. This is a brown color solution. So the iodine we have produced is a brown color. All right, so at this stage, we're going to jump into some of the questions. That's all we know for now, but so we're going to do a few of the theory questions. We're going to do question 1, part A here. And it says describe, and it's looking for 12 marks. So I'm thinking about what kind of detail do I need here. Describe how the 25 centimeter cube sample of the original bleach was diluted to exactly 250. Now think about the detail here. This is 12 marks, so we need at least 4 by 3 scoring points. We need at least 4 points. So my suggestion here is to have at least 4 to 6 bullet points here if you can. Being as detailed as you can, how you took 25 centimeters cubed, which you told us we measured out in a pipette. And then how do we dilute it to 250? So pausing the video and discussing that now. Okay, so you should only be playing if you have actually described how we dilute. Now we're going to the marking scheme. Here are the scoring points here. So each of these bullet points here is something you can score marks for. So pausing the video and going through these now and seeing how much you would get. Notice here that some of these marks are obtainable from a diagram. So if you have time in an exam, always a good idea to draw diagrams of what you did. Because sometimes if you haven't used the right accurate words, but they can see you know what you're doing using diagrams, you can get the marks. Now, I would never say just draw a diagram. Draw a diagram as to accompany an explanation if you've got time, right? Okay, so let's go through these. You know yourself, hopefully, if you've got them right. First of all, we need to pipette our 25 centimeters cubed into a 500, and it's a volumetric flask is the name of the flask that we're going to do the dilution in. That's what we always make solutions up in, volumetric flask. Then we need to top it up. So add the ionized water until near the mark. So we want to stop before the mark. So add it carefully up to close to the mark. Then add dropwise or using a dropper or a wash bottle. That's usually how my students do it, using a wash bottle. Use a wash bottle to add more water until the bottom of the meniscus is on the mark. Or you can get a mark for saying the flask reading at eye level. Now notice here, this section here is all one bullet point. So that means you can have the marks for either bottom of the meniscus on the mark or read at eye level. You can't have the marks for both. You can't have 3 for this and 3 for this. Okay, so that means we need to go to a different bullet point here to get the other 3 marks, if you get what I mean. Stopper and invert is one way, mix thoroughly. Stopper and invert, mix thoroughly. Again, those are one or the other. You can't have marks for both of them. So that's what this double dash line means. You have to have something from this section. You have to have something from this section. You have to have something from this section. You have to have one thing from this section, but you can't get marks for both. Okay. And again, you have to get to 4 times 3. So looking at your answer carefully, did you have enough detail? If not, add to that detail now and try and get that as your note. So this is what I'm going to study for this little explanation. Okay, back over here now. Part B, it said, what color developed in the flask when the potassium iodide and sulfuric acid were reacted with the dilute bleach in the conical flask? Okay, so when we mix these 3 things together and we got these products, what color developed? What did we see? Pause the video, write down your answer. This is part B, and it's the first one, B part 1. Pause the video. Okay, so as I told you here, it's iodine that's produced, so this is going to be brown. Or you might have described it as like a reddish brown. Okay. And then next thing is give 2 reasons why this had to be in excess, the potassium iodide. So see, it says solution of potassium iodide, Ki is added, and it says now, why would it have to be in excess? So Ki in excess, why is that important? Pause the video and write down your answer for those now. Okay, well, remember, we've added a certain amount of chloride ions, and we want all of them to convert to iodine, so that whatever concentration of this we had produced the full concentration of iodine. So we want to make sure that there's more than enough iodide to make sure all of the hypochlorite ions turn to iodine. All right, let's go and check our answer over here. What does it say? So that all the bleach has reacted. That's what we want. All the bleach has reacted and we've produced the maximum amount of iodine. And also we want to keep the iodine in solution. If we don't have enough iodide ions, some of the iodine will convert to iodide ions. So we want to have lots of iodide ions in there to keep the iodine in solution. Otherwise, it'll stop being soluble and it'll fall out of solution. All right, so I appreciate that one there was tough. It's a little tricky part of the theory. What we'll try and do for my students is I'll try and add that little question there to the carousel, so that just in case it ever come up again, it's a little bit tricky. It's not something I see very often, and those little bits, it can be helpful if they're on the carousel so that we see them more often than we would just going through exam questions. All right, back over here now, we're looking at, okay, are we into a calculation? No, not possibly not just yet. But here there's more information. So I'm going to ask you to pause the video and read that piece of text down to there. Pause the video, do that now. Okay, so once we have made this iodine solution using the first reaction, we are then going to take this and react it. It said it with the solution in the conical flask was then titrated with a 0.1 molar solution of sodium thiosulfate. The average volume of sodium thiosulfate required in the procedure was 16.1 cm cubed. Here's the balanced equation. And there's a bit more theory before calculation. So what I'm going to do is we're going to look at part C and we're going to answer that. It says, what was the purpose of standing the conical flask on a white tile? Why would you use a white tile during an experiment? All titrations have this white tile. So we're going to pause the video and write that down now. Okay, so that's hopefully pretty obvious. We want a white background so we can better see the color change. Easier to see the color change, something along those lines, pretty straightforward. Let's go on to D. Name the indicator used in the titration and state the color change observed at the end point. Now be very careful here. So indicator, And what was the end point color change? Color change. All right, so pause the video and having a go at those now. Okay, so first of all, the indicator was starch solution, starch, okay, and the color change at the end point. Now, you might be tempted to think that it started as brown, but it didn't start as brown because we didn't add the starch at the beginning. What we did is we titrated against the thiosulfate till it went pale yellow. So we added the thiosulfate until it had gone from reddish brown, had faded to pale yellow, and then we added the starch. So what color does the starch go when it's mixed with this iodine solution? And then what color does it go at the end point? So there's a little bit of help if you didn't already know it yourself. Okay, so when we add the starch, it makes the solution go blue-black. So we add the starch near the end, but not at the end. And it starts then as blue-black. Okay, that's the color it is before the end point. And then at the end point, once all the starch has been used up, once all the iodine has been used up, it has reacted with the thiosulfate. There's no iodine left in the flask anymore, so there's nothing to keep the starch blue-black, and therefore it goes to colorless. So that's your color change at the end point. All right, we're on to the calculation bit now. It says to calculate the concentration of NaClO in moles per liter, first of all of the diluted bleach, and then of the original bleach. So we're doing part E first. Now, most of you guys at this stage should or could be able to pause the video and have a go at this now. All right, if you've had a go, the correct answer you're looking for is, for part 1, what you're looking for is 0.032 molar. Okay, so well done. If you got that, you can go on to the next bit. If not, you can watch along with me as I show you how to do it. So the titration reaction is this second equation. So I'm going to begin by writing down the two reactants here. We've got 2S2O3 2-, and that comes from the CO sulfate. And here it's reacting with the iodine that we made in the conical flask using the first reaction here. Okay, so this is the reaction happening in the titration. And the first thing I need to know here is what is the concentration of each of these and what is the volume in liters used of each of these. So if you didn't know how to do this or you didn't know how to get this started, pause the video and see can you fill in the information on them arrows now, please. All right, well, the first thing we know is that it told us the thiosulfate was a 0.1 molar solution of sodium thiosulfate. There it is. So this was 0.1 molar. And I advise my students, what does molar mean? Molar means moles in 1 liter. That's what we started with, 0.1 mole per 1 liter. That's what it told us. Now, we used a certain volume of this. It was 16.1 centimeters cubed, and in liters, that's 0.016 liters, or 0.0161, sorry, liters. I hope you guys know how to do that, because I've done it loads of times in these videos. The iodine, on the other hand, well, we don't know the molarity of this, because we put it in the flask, sure, and it reacted, but we don't know what the concentration is. And we're trying to find the concentration of the diluted bleach. But to do that, we have to find the concentration of the iodine that reacted in the titration. Once we know that, then, if we know the concentration of that, well, we can go back up to the first equation and use this molarity to find the concentration of the hypochlorite. So it's a little bit more complicated than your other titrations, so there's 2 reactions involved. But how much of the iodine did we use? It told us we added 25 centimeters cubed to the bleach, and that was the limiting reagent. So that means 25 centimeters cubed of the iodine was created. So 0.025 liters. So we're going to find the concentration of iodine, and that's going to help us understand the concentration of the bleach. Okay, so let's go ahead and work to find how many moles of thiosulfate we use per titration. Pause the video and do that now. Okay, well, we know our solution of thiosulfate is 0.1 mole per 1 liter, but we didn't use 1 liter, we used 0.016 liters, 0.0161 liters. So when we do that calculation, that will give us the moles of thiosulfate. Okay, so get your calculator now, and you're doing this for me. 0.1 over 1, so 0.1, and it's times by 0.0161. So that gives me a moles equal to 1.6 1.61 times 10 to the minus 3. And that's moles of thiosulfate, S2O3, 2 minus. Now I want to find out how many moles of iodine did that react with. So pause in the video and do the next step. Find the moles of iodine that this reacted with. Well, as you can see, this is a 2-to-1 ratio. So there was twice as much steel sulfate for every 1 part, 2 parts steel sulfate for 1 part iodine. How do we do that if we're not sure? It's 1.61 by 10 to the minus 3, and this is moles of S2O3, 2 minus, and we want to convert from S2O3 2 minus, we want those to be gone, moles of those to be cancelled out here, and we want to convert to moles of I2 on the top here. And of course, then we're looking at the ratio. Well, it's 2 of these for 1 of these. Okay, so the answer I'm getting here is 8.05 times 10 to the minus 4 moles. And that's moles of I2. Okay, moles of I2. Now there's another step, okay, to get moles of I2 and find out, well, what is the equivalent number of moles of hypochlorite? Because that's what we're trying to find up here. Well, as you can see here, there is 1 I2 for 1 hypochlorite, okay? So what we can do then is now convert from moles of O2 to moles of I2 to moles of hypochlorite. So pause the video if you can do that now, please. Okay, so this many moles, 8.05 by 10 to the minus 4, and that's moles of I2 times by, well, we want to get rid of moles of I2 and find out, well, what's the equivalent number of moles of the solution is sodium hypochlorite, NaOCl. Okay, and of course that gives us the OCl minus ions. And the ratio here is 1-to-1. That's what I know from the first equation, remember. 1 I2 for 1 hypochlorite. All right, so, and why you might be asking, well, why is that hypochlorite and this is sodium hypochlorite, NaOCl? Well, the sodium hypochlorite gives us the hypochlorite, but the sodium isn't really involved. It's still part of it, it just doesn't take part in the reaction. So for every one OCl, there is 1 NaOCl. So this is why this is appearing in this formula. This is the full formula, but it's only the OCl that takes place in the reaction up there. All right, so that means it's the same number of moles. It's 8.05 times 10 to the minus 4, and we're now gone from moles of I2 is gone, and we're moles of NaOCl. Now, going back to the question here, it asked us to find the moles of NaClO, but moles per liter. Okay, so we had this many moles, but this wasn't in a full liter. So what volume of this was this in? Well, this was in how many centimeters cubed of the bleach were added? Well, as you can see here, the diluted bleach, there was 25 centimeters cubed put into the flask. So this was in, as we said here, this volume here, 0.025 liters. So now we've created the unit moles per liter, and that was this many moles in this many liters. So this many moles in this many liters. So if we put that in our calculator, it'll give us how many moles there would be in 1 liter. So 8.05 by 10 to the minus 4 over 0.025 liters. And what that gives us is 0.0322 is what I'm getting. Okay. And 0.0322 molar. And this obviously has rounded it. When I gave you this answer, this rounded it to 3 decimal places. So 0.032. All right, so that was for the diluted bleach. So what would the concentration in moles per liter of the original bleach be? So now that you have this, or if you didn't get this, you can use this now, take this down, and you should definitely be able to do the next bit. Okay, so how many moles per liter in the original bleach? So go back up here and remember what our dilution was like. I marked it out here. Okay, so what you have to do, pause in the video and doing this now. Okay, well, if this is the concentration of the diluted bleach, 0.0322, we'll keep the decimal place. This is the diluted bleach. What do we have to do to it? Find the concentration of the original bleach. Now think about this. Is the original bleach going to be a higher concentration, more number of moles per liter? Or is it going to be a lower concentration? So is the number going to get bigger or smaller? Pause the video and work your way through this. Okay, so it's going to get bigger concentration. The original concentration was more than this, so I'm expecting a higher number. And it was a 1 in 20 dilution. So I'm going to take this concentration and times it by 20 to get the original concentration. Okay, so what I'm getting here is 0.644, and that is correct, molar. So this here is the original. All right, so now we're going back up here. What does it say now? It says, what is the concentration of hypochlorite in the original bleach in grams per liter? All right, so what we got to do is take this number of moles per liter. So remembering always that capital M means moles per liter, and find out how many grams per liter that would be. So you taking over from this point, convert this to grams per liter of sodium hypochlorite. Remember, it's this substance here. You will need to know that. Pause the video and do that now. Okay, so remembering that we have 0.644 moles of it's NaOCl. I was going to use the wrong formula there, OCl, and that's in every 1 liter, because that's what molar means, moles in 1 liter, moles in 1 liter. Okay, and we want to know how many grams there would be in 1 liter. So the volume is fine. We don't want to get rid of that, but we want to get rid of moles. So we're going to times it by, in the denominator here, moles of NaOCl. They're gone. And we want to convert so that we have grams of NaOCl here. Okay. So the question is, well, how many grams of NaOCl are there in 1 mole? So pausing the video and working that out now. Okay, so hopefully you understood that you were looking for the molar mass. The molar mass. So the molar mass of NaOCl, what I'm seeing here is 74.5. Well, hopefully that's what you've got, 74.5. So once we do that then, I'm pausing the video, I'm working that out, do that now. Okay, so I'm getting 0.644 times by 74.5. I'm getting 47.978. And my units are, well, I've got grams of NaOCl as a unit that's left, grams of NaOCl. And on the bottom here, I've got liters. So grams per 1 liter of NaOCl. All right, that's that bit done. And very last bit, find it as a percentage weight per volume. So percentage weight per volume. So pause in the video now and working out what the percentage weight per volume is of this substance now. All right, so first of all, to do this, you have to understand what that means, percentage weight per volume. Percentage weight per volume is find the weight in grams. Okay, and we've already got it in grams here, but it's percentage. So grams in 100 centimeters cubed. Percent means per 100. And I'm talking about per 100 centimeters cubed. So we want the volume down here to either be 100 cm cubed, or you can think of it as being 0.1 liter. Those are the same thing. Okay, so what we want to know is we've got grams in 1 liter. We want to know the grams in 0.1 liters. So pause the video and do that now. All right, so hopefully you understand that if there are 47.978 grams per 1 liter, if we want to know how many grams there would be in a different number of liters, we need liters to cancel. And the liters that we're going to use is 0.1. So that's going to give us 47.978 times by 0.1. And that gives us an answer of 4.7978. Yeah, that's the correct answer there. And well, we can say that that's percent, because this means that there are 4.7978 grams per 100 centimeters cubed, or the solution is 4.7978% hypochlorite. So what would the rest of it be? If this is the percent of it that's sodium hypochlorite, the rest of it's probably water mostly. So probably this much, this percentage hypochlorite in the 95 point whatever leftover percentage there is. The rest of it is water. All right, guys, so hopefully it wasn't too tricky. There were certain few bits in there, especially the idea that we have two different reactions going on here. We first have to make the iodine solution from the hypochlorite. And the reason why we have to do this is because, well, hypochlorite ClO minus doesn't directly react with sodium thiosulfate. We can't just do this directly. We can't take ClO minus and directly titrate it with S2O3. That reaction doesn't work. So instead, we must first convert hypochlorite to iodine and then react the iodine with the sodium thiosulfate. So it's like a roundabout way of finding the hypochlorite concentration in bleach by converting it to iodine and then reacting the iodine with thiosulfate. So that kind of gives us an extra layer to this calculation, if you like. All right, guys, I hope you found the video useful. I hope it wasn't too much of a hang-up. I know some of my students were asking me to do this one because they weren't sure. I'd say it was the two different reactions that kind of caught them out. That's it, guys. I'll see you in the next one. Take care.